Ever get that feeling? When you have a killer app idea, maybe a game-changing piece of software, but the jump from that concept to actual code feels impossible. Like, are we even going to try to build a bridge over that gap today?
Yeah, a lot of people get stuck there. You're not alone. It's
Yeah.
like you have all the ingredients for an amazing meal, but no recipe.
Exactly. And luckily, we have a roadmap to guide us. We're going deep into the Algocademy blog's article, breaking down ideas, how to translate concepts into code, and I, for one, am curious what they highlight.
Well, they start by emphasizing that this isn't only about coding. This is about structured problem solving, like those tough interview questions at big tech companies. They're all about how you break down complex scenarios.
So it's valuable even outside of programming. Interesting.
Absolutely. And what's really fascinating is that the article says there's a more effective process than just diving in head first, and they lay out 5 key steps.
Okay, I'm ready. I'm all for a structured approach. What's the first step?
Understanding the problem.
Yeah.
Sounds obvious, right?
Yeah.
But they make a point that most people rush this part.
I can see how that happens. You get excited about the solution and forget to fully grasp the problem you're trying to solve.
Exactly. It's like starting to build a house without a blueprint.
Mm.
So they emphasize taking the time to define the problem clearly, figuring out the inputs, the desired output, and ironing out any ambiguities.
Makes sense. So once we have that understanding, what's next?
Breaking the problem down. This is where you avoid getting overwhelmed by the big picture.
So instead of trying to build an entire house at once, we're figuring out the individual components. The foundation, the walls, the roof.
That's the idea. They call this decomposition, identifying the core tasks. And then you figure out the relationships between them, what needs to happen first, what depends on what, and so on. Kind of like creating a recipe for our code.
I like that analogy, a recipe for code. So after we've broken it down, what's step 3?
Planning the approach. You choose your tools, decide on data structures, and maybe even sketch out a rough plan in pseudocode.
Okay, pseudocode. Now, I know some of our listeners might already be familiar with this, but could you give us a quick refresher just in case?
Of course. Think of pseudocode as a simplified draft of your code written in plain language. It helps you map out the logic without getting bogged down in the specific syntax of a programming language.
So instead of diving straight into the technical jargon, it's like outlining the steps in plain English first.
Exactly. The article gives a great example using a sorting algorithm. It can get pretty complex, but they write it out in pseudocode first, and it makes the actual coding process way smoother.
Makes sense. So we've got the problem understood, broken down, and planned out. So we're finally ready to start writing code right.
You got it. Step 4 is implementing the solution. And here, they stress the importance of starting with a basic implementation, focusing on one component at a time, and using clear, descriptive names for your variables and functions.
So instead of trying to build the whole house at once, we're focusing on getting one wall up, then another, making sure each piece is solid before moving on.
That's a great way to put it. It's all about building a strong foundation. And this way, you avoid a tangled mess of code that's impossible to debug later on.
Right, because debugging can be a nightmare. So what's the final step in their process?
The final, and arguably most crucial step, is testing and refining. It's not enough to just build something. It has to work correctly and efficiently.
This is where we make sure our house is stable and livable, right? We're checking for leaks, making sure the doors open and close properly, and that the roof doesn't cave in during the first rainstorm.
Precisely. And they emphasize that testing isn't just about finding bugs. It's about ensuring your code is efficient, readable, and maintainable. It's about fine-tuning your creation.
So we've got the 5 steps down, but honestly, sometimes just knowing the steps isn't enough. Sometimes it can still feel overwhelming to translate a concept into code.
You're right. That's why the article also digs into some strategies to make this process smoother, less intimidating. And I think some of these are really clever.
I'm all ears. What kind of strategies are we talking about?
Well, the first one they highlight is the power of abstraction. It sounds complicated, but it's really about simplifying things.
Abstraction, huh? That reminds me of abstract art, which can sometimes feel pretty complex.
Uh-huh. For you should say that. They actually use a simple analogy to explain abstraction. Building a car.
A car? I thought we were building houses.
Haha. Bear with me. Think about all the complex systems in a car. The engine, the transmission, the electrical systems. To code all that from scratch would be a nightmare.
I can only imagine. So how does abstraction help?
Well, abstraction lets you represent those complex systems with a simpler interface. Like in code, you might define a car class, with properties like make and model, and methods like start engine and drive.
So instead of coding every single function of a car from scratch, we create this simplified car blueprint that we can then use to build different types of cars.
You got it. It's like having a blueprint for a house, but then you can use that blueprint to build a whole neighborhood of houses, each with its own unique features.
That makes a lot of sense. It's like creating a template and then you can customize it. So abstraction helps us manage complexity. What other strategies did they mention?
Well, they also highlighted pseudocode again, which we touched on earlier, and I think this is where it can get really powerful.
Right, that human-readable draft of our code. I'm curious, how would you use pseudocode in a real-world scenario?
Okay, let's say you're working on a complex algorithm, like figuring out the shortest route between 2 points on a map. Before you even touch a line of actual code, you could write out the logic in pseudocode.
So you'd be outlining the steps like calculate the distance between point A and all its neighboring points, then compare those distances and so on.
Exactly. It helps you think through the steps logically without getting bogged down in syntax. It's like planning your route on a map before you start driving.
I see how that could prevent getting lost in the code later on. What else did they mention?
They also emphasize the power of diagrams, which I think is often overlooked.
Diagrams, you mean like flowcharts and stuff?
Yes, exactly. And even simple sketches on a whiteboard. Humans are visual creatures, and sometimes seeing the structure of your program visually, can unlock insights you might miss when just looking at lines of code.
So it's like drawing a blueprint for your house, but for your code. Helps you visualize the layout and how everything connects.
That's a great analogy. Now, another strategy they highlighted is starting with what they call a naive solution.
Naive solution. Does that mean a solution that's overly simplistic, maybe not the most efficient?
Exactly. Sometimes the best way to tackle a problem is to just start with a simple, straightforward solution, even if it's not the most elegant or optimized.
So it's like building a basic treehouse platform first, then adding the walls, the roof, and all the fancy features later. You're getting something functional up and running first.
You got it. It's about getting something working and then iterating, refining, and optimizing from there. And sometimes, in the process of building that naive solution, you uncover insights that lead to a much better approach.
It's like you start building a simple treehouse, and then you realize, hey, if I move this support beam over here, I can add a swing.
I love that. You're already mastering this whole analogy thing. Now, the last strategy they emphasized is using analogies. I think it's a brilliant way to make complex concepts click.
I'm a big fan of analogies. They can make even the most abstract ideas suddenly make sense. What kind of analogies did they use?
Well, they used a brilliant one to explain the concept of a stack data structure. Imagine a stack of plates.
Okay, a stack of plates, I'm picturing it.
With a stack of plates, you can only add a plate to the top, and you can only remove a plate from the top. It's the same with the stack data structure. You can only add or remove elements from the top. It's a last in, first out principle.
Ah, I see the connection. So this simple analogy suddenly makes a stack data structure much easier to grasp.
Exactly. And they use other analogies throughout the article to explain things like queues, trees, and graphs, making these potentially abstract concepts much more relatable.
It's like they're taking these complex coding concepts and grounding them in everyday experiences. Brilliant. But let's be real, even with all these strategies, translating concepts into code can be tough. I'm sure our listeners have run into their fair share of challenges.
You're absolutely right. And the article doesn't shy away from that. They actually dedicate a whole section to the common challenges that developers face.
I'm glad they addressed that. What kind of challenges did they highlight?
Well, one that a lot of people struggle with is analysis paralysis. You get so stuck in the planning and overthinking phase that you never actually start coding.
Oh, I know that feeling. It's like staring at a pile of lumber and tools and feeling completely overwhelmed by the task of building a treehouse.
Exactly. And they offer some great tips for overcoming this paralysis, like setting time limits for the planning phase, breaking the problem down into smaller chunks, and just focusing on getting something, anything, working first.
So instead of trying to build the entire treehouse at once, maybe just focus on building the ladder first, or even just one step of the ladder.
Exactly. Break it down, make it feel less daunting, and get that momentum going. Now, another challenge they discuss is dealing with ambiguity. Sometimes the problem itself isn't crystal clear.
Right, and I can see how that would be especially challenging in a real-world setting.
Absolutely. In those cases, they recommend not being afraid to ask for clarification. making reasonable assumptions and documenting them clearly and designing your solution to be flexible.
So if you're not sure what kind of wood to use for your treehouse, ask for clarification. Or if you're not sure how much weight it needs to support, make an educated guess and document it.
Exactly. And maybe you design the treehouse with a modular approach so you can easily reinforce it later if needed.
That's a great way to think about it. So we've got analysis paralysis and ambiguity. What other challenges did they mention?
Well, as projects grow larger and more complex, managing that complexity becomes a huge hurdle. It's easy to end up with a tangled mess of code that's impossible to maintain.
It's like starting with a simple treehouse, and then you add more and more features until it becomes this sprawling, chaotic structure with secret passages and hidden rooms and zip lines going everywhere.
That's a perfect analogy. And to manage that complexity, they recommend using modular design principles, breaking the project down into manageable chunks, and creating clear interfaces between those chunks.
So it's like organizing your treehouse village into different neighborhoods, each with its own unique style and purpose, and then connecting those neighborhoods with clear pathways.
Exactly. And they also emphasize the importance of documentation, clear naming conventions, and code comments to help navigate that complexity.
Because even the most brilliant code is useless if no one, including yourself 6 months later, can understand what it does.
So true. Now, the last challenge they address is bridging the gap between theory and practice. You can read all the books and articles about coding, but until you actually get your hands dirty and build something, it's hard to truly master the craft.
It's like reading all the books about treehouse construction, but until you actually start sawing wood and hammering nails, you won't really know how to build a treehouse.
You've got it. And to bridge that gap, they suggest things like practicing implementing algorithms and data structures from scratch, working on real-world projects, contributing to open source projects, and even just studying existing code bases to see how experienced developers tackle problems.
It's like building a treehouse from scratch, then maybe volunteering to help someone else build theirs, and then maybe even studying the blueprints of some famous treehouses for inspiration.
That's a great way to put it. It's all about immersing yourself in the world of coding and gaining that practical experience. And what's fascinating is that the article doesn't just stop there.
Oh, there's more. What else did they cover?
Well, they acknowledge that once you've got a handle on the basics, you might be ready to level up your skills.
I love that they address this. What kind of leveling up are we talking about?
Well, they introduce some advanced techniques that can take your coding to the next level. For example, they touch on design patterns.
Design patterns, what are those exactly?
They're basically reusable solutions to common programming problems. Think of them as pre-designed blueprints for common treehouse features, like a rope swing or a trapdoor.
So instead of reinventing the wheel every time you need a rope swing, you can just use a proven design pattern. That sounds efficient.
Exactly. They give an example of the singleton pattern, which ensures that you only have one instance of a particular object.
So like only having one main entrance to your treehouse village.
Precisely. And using design patterns can make your code more readable, maintainable, and scalable. It's like speaking a common language with other developers.
That's really interesting. What other advanced techniques did they mention?
Another one they highlight is test-driven development, or TDD.
TDD. I've heard of that, but I've always been a bit intimidated by it.
I can understand that. It seems counterintuitive at first, but it's all about writing tests for your code before you even write the code itself.
Wait, so you're building the test for the treehouse's sturdiness before you even build the treehouse. That seems backwards.
It does. But by writing the tests first, you're forced to think very carefully about the requirements and functionality from the start. It's like creating a detailed checklist of everything your treehouse needs to be able to do before you even pick up a hammer.
So you're not just building any treehouse, you're building a treehouse that meets specific safety and functionality standards right from the beginning.
Exactly. And while it might seem like extra work up front, it can actually save you a ton of time and headaches down the road. It helps you catch errors early on and ensure that your code behaves as expected.
Okay, I'm starting to see the appeal of TDD. I might have to give that a try. What else did they cover in this advanced techniques section?
Well, they briefly touched on domain-driven design, or DDD, which is a more holistic approach to software development. It's all about creating a shared understanding of the problem domain between developers and domain experts.
So if we're building a treehouse for a family, we need to make sure we really understand their needs and preferences. Like, do they want a slide, a climbing wall, a secret hideout?
Exactly. It's about communication and collaboration. ensuring that everyone's on the same page and that the software you're building actually solves the problem it's intended to solve.
That makes sense. It's like making sure your treehouse isn't just cool looking, but also actually fun and functional for the people who will be using it.
Precisely. And they also mentioned functional programming concepts, which are fascinating, but maybe a bit too much to unpack in this deep dive.
Okay, we'll have to save that for another episode. But wow, they really covered a lot in this article. It seems like they offer a really comprehensive roadmap for anyone who wants to learn how to translate concepts into code.
Absolutely. And the best part is they wrap things up with some actionable advice and exercises to help you solidify your understanding.
I'm glad they didn't just leave us hanging with all these concepts. What kind of exercises did they recommend?
Well, they suggested participating in coding challenges, which is a great way to put your skills to the test and get feedback. It's like entering your treehouse into a design competition.
Huh. That's a fun way to think about it. And it pushes you to think creatively and solve problems under pressure. What else did they suggest?
They also recommended implementing common data structures from scratch, like linked lists, stacks, and queues.
So instead of just using pre-built libraries, you're actually building those fundamental structures yourself.
Exactly. It's like understanding the nuts and bolts of how a house is built, rather than just assembling prefabricated walls. It gives you a deeper understanding of how things work under the hood.
That makes sense. It helps you build a strong foundation. What other exercises did they mention?
Well, they emphasize the importance of building small projects. And this is where you can really let your creativity shine.
It's like, okay, I've learned the basics of treehouse construction. Now, what kind of unique and awesome treehouse can I create?
Exactly. Building projects is where you take all the concepts you've learned and apply them to create something tangible and useful.
Hmm.
It could be a simple game, a web application, or even just a script that automates a task.
It's all about putting your knowledge into practice and building something you're proud of. And the sense of accomplishment you get from building something yourself is amazing.
Absolutely. They also suggested explaining concepts to others, which is a fantastic way to solidify your understanding. When you have to teach something, you have to really think it through and make sure you understand it deeply.
It's like, okay, I think I understand how this treehouse pulley system works. Now let me explain it to you and see if I can make it clear.
Exactly. Teaching is one of the best ways to learn. And finally, they recommended participating in code reviews, which is all about getting feedback on your code from other developers.
Because even the most experienced treehouse builders can benefit from a fresh perspective, right?
Absolutely. A code review is like having a friend come over and inspect your treehouse for any potential issues. They might spot a weak support beam or suggest a better way to attach the roof.
And in the process, you learn from their experience and improve your own skills.
Exactly. So, as you can see, this article goes far beyond just explaining the steps of translating concepts into code. It provides a toolkit of strategies, addresses common challenges, introduces advanced techniques, and even offers practical exercises to help you level up your coding game.
Wow, we really unpacked a lot from that article. I'm feeling inspired to go build something now. But before we get too carried away, let's take a moment to recap the key takeaways for our listeners. Okay, let's recap. What have we learned? Our deep dive into the Algo Academy blog's article on translating concepts into code, it was packed with insights.
It really was. We started by, acknowledging that feeling of being stuck. You have a great idea, but no clue how to turn it into code. The article gave a clear roadmap, though. 5 key steps. Understanding the problem, breaking it down, planning your approach, implementing the solution, and of course, testing and refining.
Yeah, and they put so much emphasis on that first step, really understanding the problem you're trying to solve before you even think about writing any code.
It's crucial, yeah. Easy to get caught up in the excitement of the solution and just jump into coding without really grasping the problem. And that can lead to, well, wasted time and effort down the line.
It's like starting to build a house, without a blueprint. And speaking of building things, we talked about some really cool strategies to make that whole concept to code process smoother.
Yeah. We talk about the power of abstraction, simplifying complex systems, basically, by creating higher-level representations. The car analogy was a great way to illustrate that.
It really clicked for me when you explained how abstraction lets us create a car blueprint, and then we can use that to build all sorts of different cars, each with its own unique features, like a template that we can customize.
Exactly. And then we revisited pseudocode. Such a valuable tool for planning out the logic of your code before you get into all the, nitty-gritty of syntax. It's like outlining your thoughts before writing an essay.
And I loved how you explained how you would use pseudocode in a real-world scenario, like figuring out the shortest route on a map. It helps you break the problem down into these logical steps.
It really does. And then there's the power of diagrams. I'm a visual thinker, so seeing things laid out visually, it just helps me grasp these complex concepts.
Me too. It's like having a blueprint for your code, seeing how all the pieces fit together. And we also talked about the naive solution approach, which I found kind of intriguing.
It's a great strategy. Sometimes the best way to get unstuck is to just start with a simple solution, even if it's not the most efficient. Get something working, and then iterate from there.
Right, like building a basic treehouse platform first, and then adding the walls, the roof, and, all the bells and whistles later on. Get the foundation right first.
Exactly. And of course, we can't forget the power of analogies. I mean, they have a way of making complex concepts just like click into place. The stack of plates for a stacked data structure. Brilliant.
I'll never forget that one. It made such a potentially abstract concept so easy to grasp. And they used other great analogies throughout the article too.
Yeah, they highlighted how connecting these coding concepts to everyday experiences can make them much more relatable and understandable.
But let's be honest, even with all these strategies, there are still challenges. Translating concepts into code can be tough. I appreciate that the article acknowledged those challenges, head on.
He did.
Yeah.
Analysis paralysis.
Yeah.
Getting so stuck in the planning phase that you never actually start coding.
I think we've all been there.
Absolutely. And they had some great tips for overcoming that, like setting time limits for planning, breaking the problem down into smaller chunks.
Like instead of trying to build the whole treehouse, just focus on the ladder.
Yeah. And then ambiguity, when the problem itself isn't clear.
Which, let's be real, happens all the time in the real world.
Right. So they recommended not being afraid to just ask for clarification. Make reasonable assumptions, but document them clearly, and design your solution so it's flexible.
So if you're not sure what kind of wood to use, ask.
Exactly. And design it so you can adapt it later if things change.
And they talked about managing complexity. As projects get bigger, avoiding that tangled mess of code.
Yeah. Modular design, clear interfaces, good documentation.
And they also talked about bridging the gap between theory and practice. Knowing the concepts is one thing, but actually applying them.
Right. And they had some good advice for that. Practice, practice, practice. They recommended things like implementing algorithms from scratch, working on real projects.
So you've read all the books about it. Now it's time to actually build something.
Yeah. It's all about immersing yourself and gaining that practical experience. And I thought it was really cool how they introduced some advanced techniques to help us level up.
Right. They went beyond the basics. I was interested in the design patterns. It's like having pre-designed blueprints, for common features.
Exactly. Using design patterns can make your code so much more efficient and readable.
And they also talked about test-driven development, which I'll admit seemed a bit intimidating at first, but it makes a lot of sense.
It does. It's all about writing tests for your code before you even write the code.
So you're not just building anything, you're building something that meets, specific standards right from the start.
Exactly. And it can actually save you a lot of time and headaches in the long run.
And domain-driven design, making sure you're building software that actually solves the right problem.
Right. Communication and collaboration are key there.
And finally, they wrapped up with some great exercises to, solidify our understanding.
Coding challenges, implementing data structures from scratch.
It's all about putting your knowledge into practice. I love that they encouraged explaining concepts to others. Teaching is such a powerful way to learn.
It is. And they also recommended participating in code reviews, a great way to get feedback from more experienced developers.
So we've covered a lot of ground today, from the basic steps of translating concepts into code to advanced techniques to practical exercises. I feel like I have a much better understanding of the whole process.
Me too. And these skills go beyond just coding. The ability to break down complex problems, think logically, those are valuable in any field.
So true. So, dear listener, I want you to think about this. If you could create any app, what would it be? What problem would it solve?
And once you have that idea, think about how you could break it down. Use what we've discussed today to start turning that concept into a reality.
And remember, you don't have to be a coding wizard to get started. The Algocademy blog has tons of resources to help you.
Absolutely. So embrace the challenge and, most importantly, have fun.
Until next time, deep divers, happy coding.